Go through 20, 25. We have second. On this one, we have k equals 0 to plus 1 over k. But is it geometric? Then, as that, what do I say? First few terms. So let's write a few terms of this. If we substitute in 0, yes, but is it geometric? Because the denominator's bigger isn't necessary enough for us to.
Yep, that's what I thought.
I believe this one converges. Let's back off real quick.
Broke the rules that we discussed.
We never, if the denominator diverges or converges. The only test we do, number one, we have a test that diverge terms is not 0. The series diverge. Then what? It opens the. We get to more as a first check just to make sure we're really hard when we can use this all. Stock, which if you're asking the question, write out the first few terms. So student 0 to work to the 0 plus 1, which is 2. 3 to the 0. So our first plus, then we substitute. We get to 1, 2, 2 square over 3 to the 1, which is 3. All right. Let's see if we can see the pattern. And more. Substitute in k 1, which is 3. 2 to the 3 is 3, 9. Now, could we read this? Could we? Yeah, we could. What term? 2. Okay, so we could read. Well, hold on just a second. We need to start for a geometric k is equal to 1, which is kind of a big deal. Go to infinity. Okay, our first initial term is multiplied by our. What do we need to multiply by the first term? Third. And what power? To the k power, right? To the k power. What's that?
K minus 1.
Really? K or k minus? K minus first. Yeah, the first. How come when I'm talking? The first. So when we substitute, we need to get 2. If this is the k power, we're not going to get 2. We're going to get right. So a series infinity of 2. So does that converge or diverge? That converges. And in fact, over 1/3, 2 over 1/3, which gives us 6. Right. Re-indexing. Say that. We can have a geometric. Yes, we probably can figure out it's going to convert just by looking at it, but to actually get the sum out, we have a particular form, so we can apply that particular rule to get it. What does 6 tell us? The sum of the sum to terms you're going to get to 0, but it's kind of that limiting process. We have the close. Stop it. Yeah, I don't know where the snow's coming from. I woke up this morning, I checked forecast. 0% chance. I can't tell if it's actually news. All right. Jack, and guys, I know you're saying as n gets, your behavior is going to get closer to 0, like kindergarten classes. However, I'm talking you're not. Zach. Yep. Right, choose the right word. We re-index it to a. Yeah, the first, whatever the first a value. How do we multi-term the next term? And if it has that constant rate, it is. However, we to cheat a little bit in this test. We know this, so it's a geometric or it's later on. Part of this is determining like which type, which test to run on it. An arith means the difference between the term is a like the arithmetic average of two numbers is you take the second number. You call that the mean, but as those of you that times they throw on there the geometric mean. The means being geometric implies a day of G4 ever again, but the geometric can be arithmetic. If it's in a series, there's a constant, a single, only one diverges. What's the common difference? Zero. Right. 2 plus 0 plus that one. If you started, you had 10 trillionth, an infinite number to verge. Right? You remember one add in an infinite number of times is going to grow. About infinity is that can grow without bound. There's some upper limit on this sum that, in other words, they're going to go above. That's really what the sum means in practice, close as you want it to get if terms. Can I take that in a couple days? So we got to learn more first.
That was actually for 8.4, so that was
2 days ahead of where we are right now. That does come out over k squared converges. K diverges 0, 0, 0. Like 1 is today.
K squared does.
And the bottom universe believe.
So how did they figure out that it diverges?
A couple days, and then will help you understand what that does. But there's still a box that's never like capped by 1 over k to the like k exceeds the get a couple days. And then Phoenix, and then let's Latin. Okay.
Okay.
Well, and re-indexed at correct sum because that's a k equals Logan. Fire away.
I forgot.
All right. Anybody else? Phoenix.
So where is it? So is it generics, but is it just multiple? Is that always just your first value?
Right. The formula for geometric is the sum from k equals 1 to infinity of the initial rate power. So this is where if you go get help in this chapter, there's a good factor as one because I was in a really boring meeting last period. In my book, I should have brought my calc book and prepared fine for I knew up today. And this is okay. I can do it with you. I'm not smart enough to distract. So I'm not really paying attention to this presentation, doing what we're going to talk about. Some books call this a, which then I think it's really confusing. A zero, but it starts at k equals. How can I? Yeah. Well, it's like v zero is your initial. When they didn't, you're like, but that's really the first term. That's why.
So the original series would numerator
Yep.
always just k minus 1.
This to apply the rules of trick, you have to. This is the only form that we know how to sum for, but it has to be in this specific. So, like Tain mentioned, the denominator because he paid attention. He can actually find the sum. We have to re-indicate equals 0. So again, to do writing out a few terms. You're going to have like 4 tests we have, which one it fits in. Oftentimes, if you have a few terms, you can't use. Take a look at another one.
Still forgot my question.
Sorry, brother. AP 1 was another question from k equals 1 to infinity of 1 plus times k. Now, intuition, does converge or diverge? Foil this out, use the sum for infinity of 1 over k squared plus 3 plus 2. I'm trying to break it up.
Actually, no.
Hi. It's already broken up.
I don't think you need to do that, though. Ideas on what we can do to move this. And some from Kitty. Okay, I have no idea. K, 1 over k to the p power converges when p is greater than 1. So let me ask you a question. Series. How do you know? Think about it. Hold on. Think about it. We think with our brains, not our mouth, boys. Brain. Second. When you got a good answer, raise your hand. Good answer, raise your hand. Miles.
When it went to the same power as it gets closer to infinity, the other terms matter. Arbitrarily large compared to
Well, as you plug
First.
as you infinity,
Okay. Else?
9,999,900 larger.
Okay. Again, one more formal math. Yep.
Basically, what they said. I just wanted to raise my
Okay.
pretend that I knew something.
Okay. Enthusiasm.
That gives you plus.
Okay.
As k gets infinitely large, those in third term.
Okay. It does. Anybody else? Good.
What's that? Go to 0 faster. K squared is 3 than just k squared. So
Question. The terms of compared to the series, how keep each other? Which ones?
no.
Denominator. The whole term is less because the denominator is. You get your notes. It's like exactly step in today's lesson. Today we're going to learn some more ways of convergence and divergence, and we're going to conversion. Theorem as like our last chance. We have no other way to do it, so we just say, well, it's always between. What's that? One of those for conversion. Say, let. What's that? Oh, this is going to start. What in your book in section 8.3. Yep, I've been recording the whole time today. I knew that question. I knew the lesson. I didn't want the lesson to start without leading one. And damage theorem for conversion says let the sanity of series A of n be 1 to n. The sum is 1 of n, which is sum is 1 of c of n. So in other words, sum from these two others. For a of n, we don't know what it is. It lies between f equals 1 to infinity of b of n and equals 1 a of n converge converge, then what does A of n have to be?
Convergent.
We see two convergent for a sum instead of a limit. We sandwich. I have this problem. You guys state series is always in terms of this series because the denominator larger. So I know one. I know one. I'll move up. Infinity and 1 over k squared 3k plus equals 1 squared. Is that relationship true?
Yeah.
Yeah. In terms of this series, we'll have a small denominator series test that one converts. Question is, what do I do to even easier? Easier. Easier.
Why don't we just do
4? 0. The sum of an infinite. Yeah! Okay, I hear you guys, and what you're saying, but if we're going to is possible greater than 0, are they going to get rid of it? But is this only times? Is 0 convergent? Yeah, you ate a deadbeat dollars every day. So the sum to that these both convert. The one on the left because of the series test, therefore the sum to infinity 1 over k squared plus 3 converges.
really need an explanation?
Almost always on the multiple choice, but this allows you to just know that it's going to work. Because if you can sandwich it between two convergences, you know it. Always, what do we use as our other? Why wouldn't we? Yep. Is that good enough, Braden? Yeah. The majority of these become alternating series. There's something you can alternate. The only problem with this is it's not. It will have it's always. You can't use the word always because this has a negative k power, a negative. So if I put this in here, like if I put -1 to the k, then it alternates between being positive and negative. Which is as long as it doesn't alternate between positive and negative, yeah. And 0 certainly converges. The fine, but use terms because these terms are always going to increase it. That's a minus 3k, and we may not. Logan.
An example one would be 1 minus 1/2 plus 1/5 off the.
So, but go to conclusion though.
So
1/2 minus 1/16 today. Other question. All right, let's really only have 3 tests right. You have that limit one, which I'm going to give a full name and just a series test, and we have the sandwich series. It converges. The converse to that, though, is if it in series, what is that series? The diverges. Why would we? More tests. Tests several days.
how many?
Really down the P series test. The sum from k equals 1 to infinity of 1 when greater than 1 divergent and P is less than or equal to 1. Yep. I'm just getting informally down. We have so you name, but now we're ready. The nth test for
Something.
if the limit as n goes to infinity, then the sum to infinity must diverge. Test for dot. Now this is always our. Now when we do harder stuff, you get used to it. Sometimes we've worked like 4 or 6 tests and we still can't because we should have done this test first. You the terms are not going to 0. We cannot have a conversion. We don't need to run anything else. On the AP test, nasty. The limit of the terms is going to 0. All the are on. Easiest test. Or you go doing terms going to 0. Figure it out. Whether it's going to die. Now, if then the terms are going to 0. So if the series converges 1 to infinity of a of t of a of k, then the limit must 0. Right. That's why it's not got an if and only if in there. If the series converges to go to 0. Now, if one of the terms goes to 0, it could convert. If them don't.
This is probably something not important. Convert or the converse.
Converse means we take the statement, so it becomes then it becomes the b then a.
It sounds like
It was.
It's like, it's a rectangle, but if it's a rectangle, that's what it means.
True. It could be the converse. If I me
snow squall, the winter and
or sorry, Phoenix. And okay, snow squall. It was fun. Yes, Phoenix. The only time it works is what do we use that for a lot to sandwich it in between complex, especially if the terms are confused. Then one more, and then the integral test.
oh boy.
I told you before. It's for America. We raise our hands. Hold on, just a second. It's far easier for a series to convert. Integral. The series to convert up every single value. F1, F1.2, F1. Series just 2 plus F. It's far easier. The series to convert. So, the America integral of f of. So, in other words, the integral converting series that. If the integral converges the series, but this also has a second. Hard. I can't. If the integral diverges, then it diverges. K converges. Yes. 0.9%. I can teach with kids talking. Doesn't bother me that much, actually. This is too hard. Give you a clue that this is too hard.
Well, I thought you said like it's harder for like girl to not. Doesn't that mean like the change?
No, but if the integral diverge as well.
Any difference between it? Converges in the series and the series that is harder?
that not what I just...
Yeah, but you said like, yeah, but you said to do that, then it's always the same, then how is that?
Notice there's no e. It's far for the integral here.
Yeah, so then shouldn't there be more diverse
Series that...
I think we're just doing this like so easy to work.
So, if fit it into one of the boxes, find the integral of it, we can use integral to determine integers. Now, by saying find the integral, does it converge or diverge? We have to use know how to find the integral of any point. You have everything you're going to till you get, and you can just find out. This isn't all of us for everything, but it give us a way to determine converges or diverges. Satisfying too. Before I take more corpus, but I want to look at what do I? Let's do this one. The sum over yep. Example. First one. AP number 1. From k equals 1 to infinity of 2k is 2. From infinity of 2k. Just to what? Are the terms going? Yeah, limit is n goes so it is it a P test? Could we sandwich both the numerator and could? And is that going to go to 0? We're going to have a 2 pop k for k add enough to make it diverge. First thing we are the terms. Yes. That tells us. Is it a P series? No. So what we have left is integral. So now I need to use the for k squared plus 2 the integral of 2x dx. I want you to get used to something that they're not going to. All right. On your review minute, what is that integral equal to? That integral. What's up? You know how to do that? Oh, now confidential information. Yeah, and unfortunately, YouTube muted it anymore. Yeah, no.
Okay. Anyway, you should be able to write me like a reference letter, especially like a generic scholarship.
Period.
To go to ROTC.
You send me an period for bluff next period.
Like,
Do it well. Yeah, you'll be received. Yeah. I wrote.
yeah,
What do you want me to do?
a copy that I could digitally and print or different. Yeah. That sounds
What type of integral? You suck. Technically, should we change into a limit? Now, do not. As long as you understand where infinity involves. These are always on the multiple choice set. These are all the time on the multiple choice test. Taylor's is what will be. It will for 6 the last of this. Get this giant birth of knowledge that helps us write a function. Waiting for them to catch. So, or how are you going to tip that poor Jimmy John's driver? Well, let's say that you lunch. What do you do if you don't have a 4th period class? I guess you're partial. Just let everybody go? Yeah, that's right. Yeah. What type? That was the calculus squared. So then du2. Yeah, 2x. Good part of these tests, it's usually if eventually learn in this chapter. What do we do with them later on to What did that do for us? Is when we can actually non-polynomial. Okay, so 1 to infinity. That is just, how about d over u? That integral equal to log close. I am going to keep them in. I'm going to in and keep them in. We should change the answer, though, Christian. Don't take that out of. Don't take that.
No.
Snow outside. Snow.
But also true statement.
Statement. All right. Then substitute u back. We get x squared plus 2. All those beeps are when I get to find out if you can't. All right. Now, all we have this does what? Diverge. If infinity, what's this going to do? Diverge. Now, here's what you actually put your answer. Here's what you actually put for answer. Or because the integral from 1 to d, it's dx. From k. Also diverges.
Guys, can you please be quiet? I'm trying to learn.
Questions on that? Questions on that? We'll get to it. Facing the seems to be dominant is E. 2, let's nasty. Nice. Not 1 over, what should we go? A times N. No. Got that wrong. Infinity of 1k times a little bit. When k equals, oh no. Is that going to work at 1? That's not going to work at 1. We started at 2. That's started at 2 later on. But from k equals 2 to the natural log of k quantities. So determinant or die or notes and bad notes and supports that way. Vanessa, is your life? Where are you? Natural log of it up the smartest. Yes. Not really. My email says it's canceled. Campus, the canyon. If you don't know, it. Wait. Yeah, why don't fire? Kevin, yes. Oh yeah.
We have to solve the integral. One over the net.
If you don't do that, so
Right, what do we got? Like what's there? Who's got this? Christian, you already talked to me. I'm thinking Mayor Warren. Mayor Warren, fire away. Hey, wait.